This is trigonometry. A fish shop has a vertical sign outside its door. In the diagram below, the sign is represented by FH, which is 3 centimeters. Okay, that's the diagram. That's what we're working off. A cable is tied to the top of the sign F and is secured at the point G on the horizontal ground. G is 1.4 from the base of the sign H as shown in the diagram. So use the theorem of Pythagoras, so they tell you, to find the length of the cable GF. Okay, so this is what we have. Dear God. This is G. This is F, this is H. We're told that this is 3 and this is 1.4. Okay, so you're asked to get the theorem of Pythagoras to find the length of the cable. So on your tables you'll see that the theorem of Pythagoras is a squared equals b squared plus c squared. It may say in your table c squared equals a squared plus b squared. You can put any one of them on the top. I've left you a set of papers, Kyra. We are on page 287. Brooks one's there, you can borrow them. Okay, so A is what we're looking for, so that's why A is the one that's on the left of the equals. Whichever one you're looking for, put on the left of the equals. So a squared equals 1.4 to b squared plus 3 to b squared, which equals 10.96. Get the square root of 10.96, and your answer is 3.3 meters. Okay? Next, you are asked to find the size of the angle FGH is 65 to the nearest degree. So FGH, so you're looking for this one here. You can use sine, cosine or tan. You go to your papers, go to again page 16 and you'll see the fractions for sine, cosine and tan. Just work out your correct lines. So this is your A, this is your B, this is your C. I'm going to use tan. Okay. So the tan of your angle, we'll call that A. The tan of your angle is the A over B. So it is 3 over 1.4. And then once you have that, that's the tan of it. You want to get the angle. Okay, that's the tan of the angle. So the angle is tan minus 1, 3 over 1.4. And you just put that straight into your calculator and you will get 65 degrees. Okay? So remember, when you get the tan first, and then once you have the tan, you can do the inverse tan to get the angle. Okay, so tan minus 1 of what your tan is will give you your angle. Okay, so part 3 then. A second cable from G is tied to the sign of point K. Have it over here. The distance is still 1.4 from H. Mairead says that the size of the new angle, KGH, is half the size of the one we worked out, which was 65 degrees, because she's saying that K is halfway up the line, which it is, so that means the angle is half, so you have to see if she's right. And it just says, is Mairead correct? It doesn't say show, verify, investigate, so you have no information to tell you whether she is or not. Just, is she correct? So, first of all, get our new measurements. If that is 3 meters, then that's 1.5 meters. And then we're going to do the same again as we just did. we're going to get the tan of our angle, which is this time, it is going to be 1.5 over 1.4. So to get your angle, it's the tan minus 1 of 1.5 over 1.4. So your answer, when you put that into your calculator, is 47 degrees, so Mairead is not correct. In part B, we have this drawing of a fish. Okay, and we have to work out stuff for this drawing of a fish. So we have our fish drawing, which is basically that type of thing. Okay, like a bow tie, except it comes down and up, down. And that goes across the middle there. Okay, so something like that. So the fish shop has a logo with some measurements. So we know that this is 12. We know that this is 10. We know that this is 37. We are told that this is 110. We are told that we have 22 and 118, 22 point something and 11.8, I think that is, and it was, 22 bang on. Okay, so that's all the information we're given. So the first thing we're asked is to work out this angle, okay? So with these, it's going to be the sine rule or the cosine rule. So you go to, first of all, look at the sine rule first, and to do the sine rule, you need to have two lines and an angle, which we have, okay? So we're going to do the sine rule for B part 1, and the sine rule is A over sine A is equal to B over sine B, and which is equal to C over sine C. So we're going to we just need two of them. So we have this 37 over 10. So we're going to take our 10 over 37 is equal to 12 over the one we're looking for, theta. Okay, so 10 over sine 37 is equal to 12 over sine theta. Okay, so we can rewrite this as 10, multiply the whole thing by sine theta, 10 sine theta is equal to 12 sine 37 over 10. Now, I have jumped loads and loads of steps there. So I'm just going to go back very quickly and show you all the steps that I jumped over here. So we had 10 over sine 37, and we had equals 12 over sine theta. What I have done is I have cross multiplied. Okay, so that becomes 10 sine theta is equal to 12 sine 37, and that's why is that over 10? As in cross multiplied. I multiplied by everything. I'm going to do this slower. So I'm going to multiply the whole thing by sine theta, and that becomes 10 by sine theta over sine 37. Okay, I'm going to do this in small steps, one step at a time, equals 12 sine theta over sine theta. These cross each other out. Okay, so you're left with 10 sine, this is the hardest part by the way, over sine 37, and here you're left with equals 12. Okay, but I want to get rid of that fraction, so I multiply everything by the bottom of the two fractions. So now I'm going to multiply everything by sine 37. So this becomes 10 sine theta by sine 37 over sine 37 equals 12 sine 37. These cancel each other out and you're left with, ignore that, that's gone a step further again. You're left with 10 sine theta equals 12 sine 37. Okay, and that's how we get to here. So we have 10 sine theta equals 12 sine 37. Okay, to find out what the sine of theta is, divide by 10. Divide by 10. So you end up with the sine of theta equals 12 sine 37 over 10. Now, just put that into your calculator. Just put all of that as a fraction into your calculator. You don't do anything, your calculator does it. Okay? And when you put that into your calculator, you'll find that the sine of theta, let's go over here. Okay, sine of theta is equal to 0.722. So to get theta, you get the inverse sine of 0.722, and that gives you 46 degrees. Okay, so just to quickly refresh that, when you get to here, multiply by the bottom of both fractions. Okay, so multiply everything here by sine theta and everything here by sine 37, and you end up with 10 sine theta equals 12 sine 37. Okay. Okay, part 2 then. You have that CF is 22, EF is 11.8, and the angle EFC is 110. So use the cosine rule and it tells you. Okay, what I find in the papers is that it always tells you if you're to use the cosine rule. If it doesn't tell you to use the cosine rule, you can use the sine rule. Okay, so if it'll tell you when to use the cosine rule, so if it doesn't say it, use the sine rule. So this tells us use the cosine rule to work out the distance of CE. So our cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so we're going to fill in what we know. So a squared equals 22 to b squared plus 11.8 to b squared minus 22 by 11.8 cos 110. Doesn't that look horrible? Do you know what? once you've filled in your cosine rule, we're going to go to the calculator and it is going to do all the rest. So you just type the whole of that into your calculator from here, keep all the brackets and everything, put all of that into your calculator, okay? And when you press equals, you will get 800.816. Cosine rule, you just put into your calculator. Once you've filled in the bits, let your calculator do the heavy lifting. Just put it straight into your calculator. Now, that is a squared. So a squared is 800.816. So a is the square root of 800.816, which is 28.3 when it's rounded up to one decimal place, which is asked us to do. Okay? Last bit, part 3. So we're asked to get the area of the whole top of the fish, of the whole fish, of the C, D, E, F, which I think is this part. Okay, so we're asked to get the area of this part, and it's told you it's symmetrical through here. So basically what we're going to do, the formula we have gives you the area of one bit, but we're going to get, it's the same, the bottom the same as the top. So the formula for the area is half, half AB sine C. AB sine C. Okay, that's what the area is. But in our case, our area is twice that. So it's 2 times half AB sine C. So if 2 times half of something is the whole of something. So the whole of that multiplied by 2, because you're getting the top and the bottom, okay, is AB sine C. Okay, it just really gets rid of the half when you multiply by 2. Now, all you're going to do is put in your bits. So A is 22, B is 11.8, and then sine C is 110. Calculator! Type that into your calculator as you see it. Okay, put that straight into your calculator and you will get 244, and it's centimeters squared because it's area. Okay, that's all you do.